Hello, everyone, and thank you for joining us for this special episode of vBrownBag. As a continuation of our Azure series, we're going to be talking about Azure Networking Fundamentals. I'm your host, Tom Green, and I'm happy to present Bryan Woodworth to discuss and go over a Networking Fundamentals whiteboarding session. Before we get started, a few quick notes. We are very interactive. If you have any questions to route to Bryan, you can tweet them at vBrownBag or with the hashtag vBrownBag, and we'll definitely route the questions and comments to him. He's also available on LinkedIn if you have any questions or direct follow-ups, and he'll share his LinkedIn information at the end of the show. We have shows all over the world at all different time zones. To check out the latest schedules and get in on the fun, go to vbrownbag.com/brownbags. And with that, I'm going to hand over control to Bryan, and you can go ahead and introduce yourself as I do so.
Great. Thanks, Tom. Hello, everyone. I am Bryan Woodworth. I am part of the Global Black Belt organization for Azure Intelligent Cloud. Basically, that's a principal solution architect role that has 1 foot in incubation and then 1 foot in solution sales and best practice. The area of my focus, no surprise, is network security, and hybrid connectivity. And we're going to be talking a lot about that today. I will try to cover these topics first at a high level, and then we'll kind of zoom into a more granular level. So we'll start big and then go towards the area of detailed focus, which is typically the VDC or virtual data center design, which is where a lot of enterprise designs end up in Azure due to scale and security. And we'll talk more about that. So let me share my screen. This will be kind of interactive and informal. It will not be so much of death by PowerPoint for this. I'm going to be doing a lot of whiteboarding. And then I have my lab up, and we'll take a look at some of these objects and concepts in real time in my lab, just so you can see what they look like in the Azure portal. All right. With that being said, let's begin. So let's talk first about the big picture of Microsoft's global network. Now, there are several clouds in Azure. We have more than one cloud. The place where most people choose to do business and build services is the Azure Consumer Cloud. This is a large global network, region situated within a large global network. We now have over 50 global regions that are part of the Azure Consumer Cloud. It's very big, large mesh. We also have some federated clouds. We have US Government Cloud, and then in that cloud we have a DDoS service. That's a separate hardened offering that's a section of Government Cloud. We also have a federated German cloud and a federated Chinese cloud. But for the purpose of today's conversations, we'll be talking strictly about Azure Consumer Cloud. Okay, so the global network that connects Azure Consumer Cloud is also the same big global network that services all of Microsoft's online offerings like Office 365, Bing, Xbox Live, etc. So it's a very large, very well-maintained, very high-performing network. It has lots of bandwidth. It has lots of connectivity into the internet at peering locations. We're partnered with over 2,500 different network peers all over the world, and it's continuing to grow. And we've been doing this network for decades, so we have a lot of experience, and we've learned a lot of really good management and scale and uptime techniques. If you're interested in learning more about our global network, you can go to our blog section on Azure.com and look at the blog entries that are written by our CVP of networking, Yusuf Khalidi, and he has a lot to say about how we're growing and scaling this intelligent network. So it's a really good read if you're interested in that topic. But we internally know our consumer network by its autonomous system, which is 8075. Now, if you're not a BGP person, AS or autonomous system does not make much sense. But know that when you're talking about one big content or network provider connecting to another and putting these together in a big array of different bubbles that are all connected across the globe to essentially service the internet, we understand each of these large networking spaces by a number, and it's called an autonomous system. So our consumer autonomous system global backbone is 8075. Inside of this global network are all of our Azure regions, of course, like this. And remember, these regions really are all over the world. So we could have, for example, US West, US East, Europe West, and say Asia Pacific, Hong Kong, for example. These are all going to be connected to each other over our private backbone, and they're also going to be situated such that you can have internet connectivity into this big cloud and use the internet to contact any of these regions globally. So one of the ways that customers like to come into Azure and do business is, of course, the internet. Now, over here, we're going to draw another network. I say OP for on-prem. This would represent a business's private WAN infrastructure. It could be an MPLS WAN, it could be an SD WAN, it could be a combination of these technologies, but a lot of big businesses and enterprises do have their own global networks. And they're connecting to Azure in a variety of ways, the internet being one of them, right? Another way that people like to connect to Azure is through a platform called ExpressRoute. What ExpressRoute does is it uses, on one side, a technology that's been tried and true called MPLS, which is how people typically build private WANs. And on our side, on the Microsoft side, it uses a similar kind of technology called VXLAN. Now, both of these technologies or protocols are tunneling protocols. They work typically at the IP level. VXLAN is actually a UDP wrapper, but they're a labeling system that allows for internet packets to be sheathed in a tunnel that provides private connectivity through a network. So you have a per tenant network. You can do some neat things when you start to build networks in this way in what's called an overlay. You can have deterministic path. You can have high uptime. You can have dedicated bandwidth. So create a private circuit, a dedicated connectivity model between a global WAN and a cloud. So ExpressRoute is a very popular way. Now, there's also connectivity technology called VPN, or Virtual Private Networks. And VPN is a large concept, and sometimes it applies to MPLS as well. It's just a way of doing a private network that's virtualized. But we also talk of VPN of the IPsec flavor. And what you're doing there is you're using a different kind of tunneling protocol, which is encrypted IP packets, to form a tunnel through a connection paradigm. And that could be the internet, or it could be ExpressRoute. So you can have VPN across both of those mediums. So it's not really so much of a third choice as it is a way of using IPsec to create a secure tunnel through either the internet or ExpressRoute for the purpose of private connectivity. All right, so all these three options are essentially on the table and in use simultaneously to connect businesses into Azure. And the question is, which one is the appropriate one? That's a simple question with a complex answer. We can address some of that, but not all of those today. I'll try to give you a high-level overview. By and large, the internet is useful for, first of all, surfacing services and applications that need to reach the broad internet user base for customers. So this could be an e-commerce application. It could be any other kind of web application or mobile application that provides application-based services to a region or a globe. And you want to surface them to the internet for that purpose. From a build and maintain perspective, the internet is often used for DevOps. When you get into more enterprise-based applications, first-class-based applications, people typically don't want to use the internet for build and maintain because of reliability or security concerns. So they'll either use a VPN through the internet to expose a private network conduit, or they'll use ExpressRoute as a private circuit, which has essentially better uptime capabilities and more fixed performance capabilities, which is a more solid foundation for build and maintain motion. All right, so let's pull up a new section here. Continue drawing. All right, so let's expand one of these regions and look at network connectivity from a regional basis. Let's pick US West, which happens to be in the Silicon Valley area. All right, so within these regions, we have both public and private resources that customers can connect to. And by public, I mean PaaS, platform as a service things. Examples would be Azure Storage. I'm not going to draw these icons because, as you can see, I'm not the most gifted artist. So I'll just kind of list them off as a PaaS offering, which lives as a multi-tenant public space. So Azure Storage, Azure SQL, Data Lake, Cosmos Database, Internet of Things, AI, machine learning, right? Azure has all these big public components that live as part of a public cloud. When you provision them and maintain them and build on them, They usually furbish you with an FQDN. Underneath that FQDN is a public IP address which faces the internet and actually can face ExpressRoute as well. We'll talk about that. And you use that as a public ingestion point for pushing or pulling data in and out of this PaaS service. Or servicing applications, again, that can service internet customers across the globe. For a lot of people, this meets their needs, but when it comes down to, again, enterprise and more of a dyed-in-the-wool networking approach where you want to build more secure first-class services, not only are you interested in PaaS, but you're also interested in IaaS, or infrastructure as a service. And the way that we expose that is in a VNet. So what we're doing is we're giving customers a construct to house virtual machines and give them private address space or address space that is owned and maintained by that Azure citizen to secure network infrastructure. And a VNet is an interesting construct. Its purpose is to serve as a holder of an arbitrary group of address blocks that are alone and isolated in the world. So I can build, say, in Azure, 4 or 5 different VNets. And each VNet, until I do specific things to connect them, has no awareness of the other VNet. I can reuse address space across these different VNets because, again, they're isolated and they're off the grid from each other. And so it's perfectly legit for me to have, say, 3 different VNets, all with the same address space in them as 3 different private virtual data centers, and run them that way for 3 different segments or sections of my business or business units or something. And that's fine, but really, in this way, if I'm reusing IP address space, I don't provide an opportunity for collaboration and elegance. And so in practice, it really isn't done this way. It's just theoretically we'll do this. Usually what happens is that VNets are connected for the purpose of growing and scaling infrastructure and building more of a traditional data center play where I want to create an existing data center footprint and manage it and scale it in the way that I would an on-prem environment. So when I build a VNet, again, I get a private, I hesitate to use the term container because that's an overloaded term, as we know, but I get a private space, a walled garden to put virtual machines inside. Now, talking about connectivity, the big picture. When I have virtual machines in a VNet, I still have a number of ways that I can connect into this space and offer services to customers. One is still the internet. So let's draw the internet over here. Actually, let's do this. On-prem again. Internet. Okay. So I can have traffic coming into my VNet over the internet. And what I need to do here is expose a public listener. So we draw in Azure like this little antenna that hangs outside of the VNet. We call this an ILPIP, or an instance level public IP. And what an ILPIP does is you marry it or couple it to one of the VNICs on your virtual machine, which, by the way, always needs to pick up an address that belongs inside the VNet. So the instance level public IP is really NAT as a service in Azure. It's tupled to a NIC such that as packets from the internet come and go through the VNet, we do the source and destination address translation for you. And in this way, we're also kind of like an internet service provider. Exactly, but what we're doing is giving you public IP space that we maintain and you rent from us. So when you're ready to connect services to the internet, again, you can build in number of public IPs and bolt them onto virtual machines in a way to surface internet connectivity, okay? Now, it's nice to have a marriage between a public IP and a virtual machine, but this isn't really ideal for high availability and scale, right? So we also have a product called the Azure Load Balancer, or ALB, and it has 2 faces. It has a public side, public load balancer, and a private side, which we call ILB, or internal load balancer. And the public load balancer will take an instance level public IP and create a virtual IP, or VIP, out of it, so that essentially what I can do, and I'm going to just draw down here, is I can have a set of back-end pool members of N size, okay? You can actually get to up to 1,000 of these now. That's a very big back-end pool, but we support that. And then I can build an Azure public load balancer that's listening on a public IP like 1.2.3.4. Okay, and then connections from the internet or another public space will come into this load balancer and it will do network load balancing or distribution to these. So that's a much more common way of exposing a service publicly in Azure. We don't have time to talk about the Azure Load Balancer in greater detail. I think that's a great future topic, but know that we have this capability. People use it for internet connectivity and high availability. Okay, so let's clean that up. So that's kind of the quick story about public connectivity to a VNet. Talked about private connectivity, of course. We need to, once again, come up with the topic of VPN. So we have in Azure, as a managed service, a VPN gateway offering. It lives inside of the VNet, so you build it and maintain it in kind of a virtual machine way. You're going to have a subnet for it. We'll talk about subnets in a moment, but you're going to give it a special subnet that it lives in called the gateway subnet. I'll just put GS for short, which is where our managed gateways go. And you're going to configure it in a similar way as you would an existing VPN appliance. You're going to choose its mode, be it routed or policy-based. You're going to choose performance, SKU, VPN gateway 1, 2, or 3, which dictate it's basically throughput. And then you're going to configure a VPN tunnel with its peer gateway, which would be over here on on-prem side. And this could support static routing, dynamic routing, which would use BGP, and a number of other things. And when you do that, essentially, we're going to create, again, an IPsec tunnel through the internet, like this, okay, between these two gateways. And the private network space that you have put into your VNet, let's just use an example, 10.1.0.020, which would be a big network space, but that's certainly supported. You now are going to expose that through the tunnel here to the on-prem side. So hosts in your on-prem network will understand this local gateway as the next hop for this private address space, and vice versa. So if we have an address block here on-prem, like 10.2.0.020, this VPN gateway in Azure will then produce an interface that's an internal interface that will expose a path out of the VNet through the IPsec tunnel to this on-prem network, and thus I've extended my private network securely into the cloud. And again, we're going to manage this for you. So you're never going to roll code on it. You never have to worry about scaling it. We do all of that for you. And it has very high availability. So it runs at approaching 4 nines. So it's 99.95% uptime on that. Again, it comes in these, it has a basic version, which is just a DevOps or, what's the word I'm looking for? Kind of sandbox product. But when you're really important, you'd want to use one of the 3 production SKUs. SKU number 1, which is a 650 megabit backplane. SKU number 2, which is a gig backplane. SKU number 3, which is a 1.25 gig backplane. Just as an aside, as a quick higher level topic, or rather more advanced topic, we do support active VPN gateway configuration. So you can exceed the bandwidth to a certain degree by running essentially 2 listeners or 2 gateway nodes inside of the VNet. It's not always going to be double the bandwidth because we don't have time to get into this, but based on the way that traffic is dispersed across those 2 tunnels, one tunnel might get more traffic than the other, or it might be lumpy because it's based on essentially network entropy of the connection material, what's called a tuple, a 5-tuple. So the source IP, the source port, the destination IP, and the destination port, and the protocol type. So you're not always guaranteed to have even hashing across those 2 tunnels, and that's not an Azure thing, that's just a network path deterministic thing. There's a very common kind of hash in the industry called a rendezvous hash, which routers use, some load balancers use, like the Azure load balancer. BGP would use it as a way of distributing traffic among equal paths. And there are always challenges in getting network to smooth out evenly across those paths. But just know that with active, you can actually exceed the printed bandwidth by some degree, which is useful. Okay. So this VPN gateway is a really popular way to set up private infrastructure. It's quick, it's easy, it uses well-known technology. IPsec has been around a long time, it's well understood by industry professionals, and we have support for a lot of different gateway types. So we have a printed matrix of all the different third-party gateway appliances that we have tested with. These would include all the common best-of-breed products like Cisco, Juniper, Fortinet, Checkpoint, Palo Alto, even F5, for example. And there's more, and so sorry if I didn't get the whole list, but those are some of the frequent flyers. Now, one thing needs to be said. We do not support IPv1, and this is a conscious decision, and this is because we do in the basic SKU, but for production SKUs, we don't. And this is because there have been some problems and some breaches with some of the ciphers on IPv1. So we want to use IPv2 and more secure things moving forward. So do know that. But it's very popular, low cost, ease of motion to create private infrastructure in Azure and then couple it up with your on-prem environment. So we see a lot of people building these VPN gateways as their entry point into Azure and maintaining them moving forward. Now, for some people, this is all they need. But for other folks, they need essentially fatter pipes. So remember, I mentioned that the VPN gateway goes to 1.25 gigabits per second, which is pretty good. But it's still going over the internet, right? And remember, the internet is a wonderful thing, but it's not always available, right? It has concerns about uptime. The internet isn't given to give you a printed SLA in the way that a private network space could. Remember, the internet is going to make some sacrifices with reliability in order to effectively balance cost, right? So people that are doing internet as a backbone service do best effort. They take it seriously, but if the packet needs to take another path because it's a more efficient path, or there's maintenance going on, or that part of the network is getting busy, then the routers will make decisions on the internet to sacrifice certain things to let that path happen. So the internet is a place where variability occurs. Your round trip times can change, your jitter can change, your packet loss can change, etc. And for some people, building first-class services on that kind of network is challenging. So they decide to move to ExpressRoute, which I discussed earlier as a private connection, dedicated connection between an on-prem private network and Azure. And so ExpressRoute requires another kind of gateway in Azure called the ExpressRoute Gateway, or the ExpressRoute Virtual Network Gateway. And it's a cousin of the VPN gateway, but it's a fundamentally different product. It's a cousin insofar as it's a managed service. It has high uptime. It comes in a bunch of different, well, not a bunch, 3 or 4 main SKUs, the standard, high, and ultra, which in many ways are scaled like the VPN appliance. So the standard is anything up to 1 gig. High is 1 to 2 gig, and ultra is 2 gig and beyond to match up with different circuit speeds. And what we do here is we essentially create a dedicated BGP circuit by using a combination of virtual appliances in the subnet, metal hosted offerings in the ExpressRoute cloud exchange, so we'll talk about that in a moment, and then the on-prem BGP edge of the customer. All right, so let's move to a new diagram and look at ExpressRoute in a little bit more detail. Okay. So I mentioned that the ExpressRoute circuit, which is a logical construct, is essentially built and maintained primarily in a place called a cloud exchange. So what is a cloud exchange? A cloud exchange is a section of a Meet Me location or data center hotel, which is dedicated to offering cloud services, both public and private, to customers that come into that Meet Me location and bring their private networks in there. So the idea of a Meet Me location has been around a very long time, as long as the internet has been a thing. These data center hotels are typically well-known, large, sophisticated places. The kinds of providers that run and maintain these Meet Me locations would be like Equinix, Cologic, Switch is a big one in Vegas, Interaction, Orange, those kinds of things. So inside of these big data center hotels exist special places where the public cloud providers, like Microsoft, for example, furbish a cloud edge so that you can directly connect fiber from one of our partners into our cloud and then get a direct connection into Azure. So I'll show you what that looks like. Unlike some of the other cloud providers, we have HA natively built into each circuit. So what we do is we surface 2 routers for each customer, an A and a B side on the Microsoft side. We call this the Microsoft Enterprise Edge. All right. And then an A side and a B side on the service provider side. So this is the SP or service provider edge. Now we have a lot of partnerships for service provider connectivity. This could range from larger well-known partners such as CenturyLink, and now that CenturyLink is about level 3, they're all folded in there together. So CenturyLink level 3, AT&T, Verizon, Megaport, Zayo, on and on. So we have dozens and dozens of different companies that can provide you connectivity into Azure that are situated within these data center hotels, these Meet Me's. And what will happen is that you'll provision some dedicated fibers running from your BGP edge into the service provider router. It's usually 1 or 10 gig, by the way. And then they will extend these connections, these physical layer 1 fiber connections, to us and maintain those for you. So we have 2 of them. And again, they are offered at 1 to 10 gig speed. Now, where this router is situated depends on how you kind of want to manage and build your private circuit. So this could be on-prem, and this conduit here could actually be essentially an MPLS VPN, right, of layer 2 or layer 3 type. So it could be a private circuit that is extended through a mesh topology coming in via MPLS into the Cloud Exchange location. It could be a legitimate physical L2 Ethernet and fiber. So it could just be dedicated hard fiber that you have running from a metropolitan area network under the street into the data center hotel. It could be a fiber that is a short haul fiber because this router is actually in a managed space inside the data center hotel itself. So you could actually extend your public and private edge up inside that data center and just have, you know, a cross connect go from your rack over to the service provider rack. So there's a whole bunch of different ways to set that up. Microsoft doesn't really see all of that physical infrastructure. We just understand from the physical viewpoint, this physical interface of the service provider router that we've faced. Okay. Once that happens, we then build a circuit, a logical construct across this infrastructure. So again, the icon of a circuit is this triangle with these circles here. And what we do is we provide an L2 and an L3 overlay for the purpose of being able to scale and offer you managed services. So at the L2 level, we use VLANs that are introduced here in the MSCE side. And then we set up a corresponding VLAN that's managed, and it's your VLAN. And the way we do this, just to be honest about it, is a queue and queue tunnel. Now, if that doesn't make sense, don't worry. What's really happening is that there's an outer VLAN tag, which is a layer 2 technology that's been around a long time that's used for multi-tenant, like MPLS at the label, okay? And this outer queue tag, which is called the service provider tag, we're going to put your tag, which is called the customer tag. So it's the S tag, actually. And we're going to put the customer tag in there. And this customer tag is what's actually going to be socialized out this way so that you can consume it over here on your side. So for example, we create a queue and queue tunnel just between these 2 interfaces, between our routers and the service provider routers. The outer tag would be 3001. You don't see that. The service provider is going to terminate it right here on this edge. So it's just between us and the service provider. And then your inner tag would be 100, say, for example. And then that would emerge on this side. The service provider will push that through. Okay. And then what goes on top of this is a BGP policy that talks about exchange. So you have the ability to express route to both consume public and private routes from Azure. So give me just a moment. I'll actually pull up a diagram of this. Great. Okay. Thanks for your patience. Here we go. Just bring this window across. So here we have a higher level diagram that shows what I was depicting, where we have this circuit, which is set up of 2 fibers or cross connects between the partner edge and the Microsoft edge and the Cloud Exchange. The customer's network comes in here on the left-hand side in green. Inside of this express route circuit is really a queue and queue tunnel at layer 2. So we're providing isolation for you at the layer 2 sphere. And then through this queue and queue tunnel, we will form 2 different kinds of BGP relationships with you in order to do both public and private route exchange. So obviously the Microsoft routing domain is the one depicted here in red. We see that this leads to public services, SaaS and PaaS things inside of Azure. And the VPN gateway is actually listening there on a public IP. So that's how people put VPN tunnels through ExpressRoute, by the way. And then this private routing domain, Azure private routing domain, which leads to your connected VNets. And that's where the ExpressRoute virtual network gateway is to, via BGP, through this VXLAN tunnel into the Cloud Exchange, send your private network address blocks from the VNet into your BGP edge so you can extend your network privately in that way. So again, a little bit kind of heavy duty here, but this is a more precise view of what's happening. The queue and queue tunnel exists. Through that queue and queue tunnel, we are going to extend one VLAN for each of these routing domains. So we'll have a VLAN to isolate public routes for you and a VLAN to isolate private routes for you. It's worthwhile to note that on these existing fibers that we have here, this primary and secondary fiber, you can build multiple circuits. Okay, a circuit is a logical construct, and it has a couple of attributes to it that helps you dictate what kind of circuit you want. Okay, so first of all, there's a speed setting. There's a bandwidth setting that comes along with the circuit. You can move from a bandwidth offering of something modest in the say 50 megabit per second realm, moving all the way through up to 10 gigabits per second. In addition, there is a standard premium offering. So there's a bit you can flip, or a drop-down menu basically, that will change the circuit style from standard to premium. What standard will do is offer you connectivity by default into any Azure region or geo, say North America. But if you wanted to move that capability globally, so in any one single cloud exchange would give you direct connectivity to any region across the globe, which is totally possible, you move it to premium type. Premium also carries a couple of other differences that we don't have time to talk about today. It allows you to connect more VNets into the circuit, up to 100 of them. A standard would cap out at 10 today. And it allows you to exchange more private routes, essentially 10,000 instead of 4,000. But for the purpose of today's conversation, the big takeaway is that standard works at a geo-regional level and premium works at a global level. There's also this idea about metered and unmetered data. And so that's another bit you can flip in the circuit to change its characteristic and the kind of circuit skew that you're consuming. By and large, metered is most efficient. That's pay by the drink. Now, Microsoft will only charge you when data leaves Azure through our edge, headed to the partner edge. It's not going to meter on ingress. So you could push us data from your network into Azure, like blob storage, for example, all day long, and you wouldn't see a penny of billing for that. It's just when data leaves Azure. By and large, most people find that metered is more efficient on the billing cycle. Unmetered, or unlimited, I should say, is basically a flat fee. It's a fat pipe. It's a flat fee for all you can eat. So you're not going to concern yourself with how much data I'm going to pull down on a daily or monthly basis. I just want to be able to consume huge amounts of data as downloaded, not worried about what kind of bill I'm going to have. My little recipe is, if you're running your fibers at around 65% link capacity out, meaning you're transmitting out of Azure into your location, that's the break-even point for those two SKUs. If you're going to run your fibers, keep them pretty busy, and you're going to be using every second of every day for every month, more than 65% of your bandwidth out, you're better at the unmetered SKU. Now, that's not always the case, but by and large, that's the kind of quick model that you could use. Now, most people don't want to saturate their circuits to that kind of capability, but you could actually get away with that in Azure insofar as, remember, you always have primary and secondary fiber. They can be configured via BGP in both active-active or active-passive mode. That's not something we're going to get into right now, but BGP has this capability of understanding equal paths. So if we go back to this diagram here, remember, we have two routers. That's just an inherent part of each circuit that you provision. So you could treat each of these routers as a equal destination for, say, your VNet or a PaaS service. And as long as your BGP edge understands that, it's basically a multipath enable option. You can burst across both of these fibers. So you're paying for 10 gig, but what you're really getting underneath the hood is 20. We want this. This is not an Easter egg. This is part of the service. This is part of what ExpressRoute is. And if you choose to use this capability, we would welcome you to do that. We just natively understand equal cost multipath, so there's not a lot of special stuff you need to do on the Microsoft side. It's just ready to go. However, if this isn't your model, if you would rather treat one of these paths as primary and then the other as a failover path, that's fine too. So you would just train BGP to understand via metrics. We don't have time to get into that, but AS path prepend is the typical way of making one path look more preferred over the other, and then we would simply fail over to the other path if the routes were drawn on the, say, the top path of the A side. Okay. Where do we go from there? Let's get back to the diagram here, show a new diagram, and talk about connecting VNets to the circuit. All right. So speaking about the private connectivity model, let's go back to our region again. All right. So this was US West. We're going to magnify again, to review, I have a VNet, and I've carved out these different subnets. And I have one subnet for a web tier. And remember, this would be, say, 50 virtual machines. Let's say this is a pretty healthy app here. And I have another subnet for a worker role, middleware, say about 50. And then for my database, in this case, I'm using Azure SQL. So I'm going to go paths there. And we're going to refer to this diagram again for some other concepts. But let's say I'm using managed database infrastructure here. And then I have my gateway subnet, again, GS. And in there, I have my express route network gateway or virtual network gateway. And what I've done is I'm going to create the circuit in a Cloud Exchange location. We have many, many global Cloud Exchange locations, right? A ton of them, which is great for your business because we have a lot of variety in terms of geographical presence to help you with your latency storage, etc. Let's just say that this one is in Silicon Valley. Okay, now we're going to handle the connection for you on this side. So it's really not only is the layer 3 BGP connection, but remember, we're going to handle all the layer 2 and layer 1 semantics. So take a minute to think about that. When you create a circuit, you're creating a virtual layer 1 fiber that's part of a large, huge global network that we're going to maintain in an isolated way for you through VXLAN. But presto chango, you're just going to have dedicated bandwidth. It's your swim lane into Azure. So some people take some while to kind of digest the concept. It's like, whoa. But yeah, that's what you have. And you click a couple of buttons, boom, you have your own fiber running from this Cloud Exchange into your VNet, okay? And it has all the various characteristics of it that you've chosen based on your SKU. So it's running at a specific speed. Let's say it's 100 megabits per second. It's going to have a couple of different megabits per second. There you go, Brian. It's going to have, in this case, a standard offering. So you're going to be able to connect that circuit to VNets in North America. And let's say it's the standard metered option, okay? And then in the Cloud Exchange, of course, you're going to have your BGP edge connecting to on-prem. Let's say in this case, you are actually having a managed service offering. So for example, Equinix, they have a way to, Equinix is just a four-walls provider. They're one of our bigger partners for ExpressRoute. And they do power and cooling and data center space. So you could put whatever kind of kit you want in their meet me location and then just punch it right over to ExpressRoute through them as a service provider, or AT&T or who, right? We love all of our partners. But let's say in this case, you're using a managed service from Equinix. They're doing the CapEx for you through a managed service offering. They have like Synoptech, and you're just doing OpEx. You're just running a monthly check for this infrastructure to be maintained for you. So your BGP edge is right here, okay? And so you have this great thing going on. You have private routes being exchanged, 10.120 here. In this case, let's just say that you're sending a larger network block through ExpressRoute. It's called summarization. It's really clever, and that's a good way of doing it. That way, this VNet only sees one single route and understands anything that's less specific than itself as simply going through ExpressRoute and out to the on-prem space. So summarization is a really nice tactic in routing to keep routing straightforward and simple. But you can do that in Azure. You can summarize and send us a big block. The ExpressRoute gateway will understand that. It will use standard kind of routing precedents of longest subnet matching to say, hey, 10.1 is my subnet. This belongs to me in this VNet, but 10.8 is a bigger subnet. In fact, one of the biggest. And so anything that doesn't match this local VNet, I'm just going to send out to the Cloud Exchange and telcos. Okay. Now this is great, but it's not enough for me. Why is it not enough? Because I'm a big enterprise business, and I need to grow my business inside of Azure. I need to be able to scale in a meaningful way, right? So as I mentioned, we're going to get into virtual data center design a little bit here. I guess I should put that on pause and talk a little bit more about this subnet as a construct, because I've introduced it here, and it bears repeating. Remember, a VNet is just an isolated construct to put in address blocks and have a multi-tenant kind of environment, so I could reuse this. But that's not helpful to me because I really need to segregate my workloads for the purposes of management security. So enter the subnet. The subnet, kind of like your VLAN in Azure, it's a way of carving out smaller address blocks. So I could say I put a 24 here, a 24 here, and a 24 here to be efficient with my IP address space so I don't waste it or squander it. And then put like kinds of workloads in these subnets. And what do I mean by like? I mean like they share so many commonalities that they essentially live in their own dedicated security zone, that there's implicit trust between all my web machines. I'm not going to worry about ACLing maybe one web machine apart from another web machine, right? They all fall under the same jurisdiction. They're all offering the same kind of service. They're all listing out the same kind of ports. They're all running the same code, so I can put them together in this and manage them as a contiguous group, okay? Same idea with the worker role. But I do say want security between web, and worker. So I'm going to use the subnet as an anchor to build intelligent whitelists and blacklists, and we call this a network security group, or NSG. All right. And the NSG is a place to write your basic layer 4 firewall policy, and it's done as a service in Azure, and it's free, which is awfully nifty, and it has a lot of scale because it's done as a managed service. So the more virtual machines I build, essentially the more resources we plumb for your network security group to work in our SDN stack. So it really doesn't tap out. It's not a choke point, okay, which is an awfully nice thing. So the bigger my VNet gets, the more horsepower I have to scale the security apparatus. But the network security group offers a couple of key features that people like, right? It has your standard order precedence, blacklist, and whitelist. It has the ability now to do logging through Network Watcher to a couple of different places like Splunk or Logging Analytics or to a blob account, so that you have auditing and compliance. So it's your basic firewall quasi-real-time log output. It surfaces a couple of other nice features, one of them which is called service tags, which is a built-in understanding of Azure PaaS services, so you don't have to figure out all these different dynamic IPs that represent, say, Azure SQL. So if I want, for example, my worker roles to have a conduit, blessed conduit to Azure SQL, I simply create an NSG rule that says allow, and I use the tag for .uswest.sql. And then that way, I get a dynamic whitelist that Azure manages that represents SQL targets, and I no longer have to say use a larger block, say internet, which is another tag, which is awfully promiscuous. So now I can be service-based, which is great. We also have this thing in NSGs called application security groups, which means I'm no longer going to identify my security policy based on IP addresses. I'm going to use it based on rubrics or strings. So for example, I could create an application security group called web, an ASG, and an application security group, ASG, called worker. And then that string, web and worker, is what I use to define my policy. So I could write an ACL that would say, okay, I want to allow web, to talk to worker on port 443. And that way, I don't have to worry about the various IP address ranges that are in these subnets or in managing all that. I could even just have it in a big VNet. So if I were into microservices and containerization and these kind of highly agile things, I could essentially abandon subnets, put all my workloads into one VNet, and just let Azure take care of the IP addressing for me via DHCP, and then understand all my security policy based on labels and tags that I put my virtual machines into. Now, I'm careful with the word tag. That actually means something else in Azure, so really label's a better term. Okay, so that's a little bit about subnets and a little bit about network security groups. Let's go again to this idea of the VNet and growing this virtual data center with an express route circuit. So let's move to a new diagram. Great. Okay. So let's draw it in a different way. I could put everything in Azure in one subnet and be fat and happy, rather one VNet. Probably wouldn't want one subnet and be fat and happy with that. That could solve your business case, and there's nothing wrong with that. It's just that, remember, in our resource governance model, we have this concept of a subscription, okay? And that's where your user identity is going to be couched. And you're also going to receive billing and consumption through your subscription model, right? So it services an apparatus for business logic, but it also services an apparatus for resource group RBAC control, meaning that I think we don't have time to talk about resource groups here. It's understood that you probably get that concept already, but a resource group is just a bucket to put arbitrary resources in to marry role-based access to them, right? So VNet live in a resource group, other networking infrastructure of like should live in a resource group, et cetera. But anyway, a subscription is where you bring your identity and management paradigm into Azure. And that's all well and good. It's just that companies, either organically or for business purposes or billing purposes or divisional labor purposes, often wind up with more than one subscription. It's just that way, and that's the way the cookie crumbles. So I might have a subscription for DevOps, because that's kind of how I began, just organically swiping credit cards, but now things are getting more real in Azure, and I need to kind of bring other workloads and business units into Azure to surface different kinds of apps, right? So I might have another subscription for IT and security, ITsec. Great. And then I might have another subscription for, let's just say, human resources, for example. All right. So these are all floating around in Azure, and they each have their own VNet, but now I need for all these workloads to fall under a central authority so I can bring in compliance and governance and surface these applications and manage them in a sane, reliable, predictable way so that I don't, say, fall into the trap of getting owned and having a breach and having all this bad PR and stuff. So it's really important to think about this stuff from a multi-tenant model. And again, businesses usually have more than one subscription going on, and they need a meaningful way to connect these and express them and manage them together. All right, so then talk about hub and spoke. So I have a VNet here, which I am going to essentially associate with my IT security subscription, right? Then I have another VNet up here, which has been in use by my DevOps, like this. And I have another subscription, which is that has a VNet, so we'll call this Spoke 1, Spoke 2. And Spoke 2 is for my human resource department. And in this way, I can connect them together and manage them. And the technology I'm going to use is called VNet Peering. Now, VNet Peering, we don't have time to talk about all the neat things about VNet Peering in our introductory course today, but know that VNet Peering uses the same software-defined networking stack that allows me to create an arbitrary VNet, allows me to create and manage arbitrary subnets, and allows me to essentially manage all the network security groups and routing without doing much work in Azure, right? Our SDN stack, which is flow-based, it lives in the hypervisor underneath the virtual machine, surfaces these virtual capabilities at the networking level such that when I want to connect or peer my hub to my spoke, it's just a few clicks away, okay? So what's cool about VNet peering is that the performance capabilities of one subnet to another, say virtual machines between subnets, are going to be identical between spokes and subnets, between spokes and VNets in the same region. There's no performance penalty for doing this because, again, it's all software, it's all tunneling, and where virtual machines are located physically within a region doesn't matter anymore. The fabric is going to do intelligent things to make sure that virtual machines line up to give you performance and uptime guarantees. Okay, so that's all part of our management paradigm. So the VNet peering is not, say, we're not introducing a bottleneck here, okay? That's my friend and peer, Jeremy Wright, who's our East Coast Black Belt, and we collaborate a lot. So there he is collaborating with me over Skype. Jeremy's a great guy. He and I worked together a long time. Okay, so you probably may encounter Jeremy one day working a case with Azure or a design session with Azure, and he is my peer. Okay, so where were we? I now have this ability to surface in the hub a virtual DMZ, VDM. And this is great because what I can do is bring in appliances and solutions that are critical for my governance and compliance capabilities. So when I'm wanting to rein in DevOps, okay, and make the services that they offer compliant and secure, and I need to also surface HR applications, internal applications, I need them to all fall under the same umbrella. My IT department needs to be able to manage them and provide services and a ticket system and help desk and all these things. And so with IT owning the subscription in the hub and my business units occupying places in the spokes and VNet peering, bringing these VNets together, I'm now kind of set up to form a virtual data center. So I can bring in firewalls, I can bring in intrusion detection systems, I can bring in identity like Azure Active Directory domain controllers, I can bring in custom DNS, et cetera, et cetera. I could bring in WAF or use the Azure Application Gateway and WAF product, all these things. And what's nice is that all of my data center kit is going to live in the hub, okay? My jump boxes, et cetera. And the resource group that surrounds them is going to use an RBAC model such that my IT and security professionals, based on their roles, could be network operator or contributor, when they log in via their subscription, they're going to see exactly what they need to see to manage it. And when my DevOps crew and HR crew log in, they are not, right? They're going to be walled away and they're going to see what they need to see, which is applications and services in the spokes. Now, when I peer spokes together, I also have an on-prem hybrid connectivity story. So let's reintroduce ExpressRoute here. I'll put H up here for hub, okay? So remember, I have this circuit, and it leads to on-prem. And I now need to have collaboration and hybridity between my on-prem data center and this virtual data center I'm building in Azure such that DevOps can see and manage between on-prem cloud, and HR can see and manage between on-prem and cloud, and same with IT and security, right? So what happens here is that I can go into my peerings and enable transitive capability through my ExpressRoute gateway such that on-prem can see spokes and vice versa. And in my VNet peering control panel, I'm going to use a feature called Use Remote Gateways. I tick a little box. And here in the hub, I'm going to tick a little box that says Allow Gateway transit. And what that does is it takes the on-prem routes that this express route virtual network gateway knows about through BGP and will inject them into the spokes, okay? So if I'm sending 10.8 up here through on-prem, that 10.8 block will then arrive here in my spoke and up here in my spoke. And this inside interface, which Azure manages, this part of the gateway subnet, will be the next hop for 10.8. So my spoke can egress easily, my DevOps spoke and my HR spoke. And as they come through this hub, I have an opportunity to bring them into compliance, either using network security groups and Azure products. We now have, by the way, the Azure Cloud Native Firewall. So this could be Palo Alto and whatever kind of cool stuff you use in your own shop, or it could be the managed service offering that we have now, like the Azure WAF or the Cloud Native Firewall. But I'm going to steer them through these virtual appliances so I can do traffic filtering and compliance kind of stuff, right? I want inspection, I want logging, I want blacklisting and whitelisting up through the stack, etc. Now, how do I steer that traffic? Enter this concept, and this will be our last concept for the talk. I know this has been fast and furious, called a routing table, or an RT. All right? And I know I promised to show my Azure lab. We might go over a little bit, and I think what I'll do is do a whirlwind 5-minute tour of the lab. So we'll talk about routing tables here for about 3 or 4 minutes and how that all works at a high level, and then I'll show you all the stuff in the lab to make good on my promise. Okay.
That's great. We always love a live demo.
Yeah, that's right. What could go wrong? All right, so the routing table, I attach it to a various subnet. In this case, I wouldn't want to attach a routing table to a firewall subnet for the purpose of this demonstration. Rather, the firewall is going to be the target of the route table. You can get yourself into some funny routing loop things when you tell firewalls to route back to themselves for a given destination. So by and large, if you put the firewalls in their own subnet or set of subnets, it's better to carve them out that way. That way, I can attach routing tables to other VNets and subnets and use them, the firewall, as a target, okay? So I'm going to build a routing table, and I attach it to a subnet up here. Let's say I have a worker subnet up here. I attach my routing table, and I write inside of it a policy entry, which is called a user-defined route. A UDR is just an entry inside of a routing table. It's a static route, okay? And I'm just going to say, for the destination of 10.8, I'm going to use a route type of virtual appliance, and I'm going to point it to this IP address. In this case, let's say it's down in the subnet. Let's say it's 10.1.1.100. Now, that could be the interface of this firewall, and if that firewall fails, it'll make an API call out to Azure to change that IP address to, say, 101, which would be the B firewall. That's fine. The convergence time on that isn't amazing because it's a control plane call. If you want faster convergence, what you want to do, we don't have time to get into this a lot, is build an Azure standard load balancer. So I would come up here and I would build a load balancer in a different subnet. You could do it in the same subnet, but people like to put it in different subnets so it's compartmentalized. And that load balancer, which would be the type standard, surfaces a feature called HA ports that just listens on star. So I just need one listener for all my firewall policy. My firewall echoing forwarding will take care of the granular stuff. Just this idea is just using it as a high availability hop, okay, to get between 2 or more firewalls. And then I would give that this IP address of the Azure load balancer 2.100, okay? And now routes are going to flow down to on-prem through this load balancer. The load balancer, which is itself a platform, it's not a single serving. Okay, so it has outrageous uptime of 99.95%. We'll make a load balancing decision. We'll send it to the firewall. The firewall then has in its Azure routing table, the route to say 10.8 at the express route gateway, and the traffic will flow here. Now remember, via BGP, the routes of the spokes will also be sent down. So on-prem natively understands that these spokes exist and that the responses should go back up the express route path to them. Azure will route them back to the spokes accordingly via the fabric. In order to get traffic to go back into my firewall for stateful purposes, I could either do NAT in the firewall, so I could change the source address to an IP that the firewall owns, okay? And then Azure will just go, okay, back to the firewall you go. That's popular. I could do another interesting thing where inside of the gateway subnet, this is a higher level conversation, well, rather technically dense conversation. I could build another routing table that would say, oh, for spoke 1, go back to that same Azure load balancer, and it will actually, the way that it hashes the packets, it would hash the response back to the same firewall, and then the firewall would get the SYNAC, for example, the stateful response, and understand that it needs to go back to spoke 1. So what you would do is, again, the route table would exist in the gateway subnet, and you would say for the spoke 1 block. Let's say it's 10.3.20. Sorry, my writing is so terrible. Go back to that same virtual appliance type, and we're going to use the IP address of that load balancer again, 10.1.2.10. Okay, so that was a really fun crash course into a little bit about Spoke and Hub inside of Azure. Note that we can now peer up to 100 spokes to each hub, and I can now connect with a premium circuit up to 100 hubs to each circuit. So you can get a very large matrix of 10 by 10, 10 by 100 on these circuits. You can get good ROI on your circuit. Even standard express route circuit, I can connect 10 hubs. You know, I could connect just 10 VNets and call it a day, but with Spoke and Hub, obviously I get scale beyond that, so that's one reason why Spoke and Hub is popular. All right, now let's look at some of these concepts in the lab. Great. So I have a Spoke and Hub set up here. If I go to my virtual networks pane in Azure, you see I have this is built in West 2, which is in the Pacific Northwest area. It's actually in Central Washington. So that's the region we're operating in. I have my hub here and my Spoke. We'll just go into VNet and Spoke 1 and 2, just as I mentioned in the diagram. So I'm just drawing out a facsimile of my lab. And again, let's use that model, Spoke 1 being dev and Spoke 2 being HR for an internal application. Here's the issue, not the issue, the control plane for address space. And you can see you can just put arbitrary blocks in here. They're additive, so I can put additional space if I want. I can actually grow this in a non-disruptive way. If I shrink it, it's going to complain and say, ooh, you can't do that because there's already a subnet that takes that block. But see, if I wanted to go to a 19, which is a bigger block, oh, there's overlap because I'm reusing it. Anyway, if I wasn't reusing it in another VNet, you can grow it non-disruptively. And it's smart, and we'll try to, it's Azure Smart, and if it is running into a conflict, it will warn you so you don't shoot yourself in the foot, which is kind of nice. But anyway, that's where the address space is carved out. Here's, as you can see, subnets. So I have a couple of different subnets. In this case, I have an external DMZ for the outside interface of my firewalls, an IDMZ for the internal interface of my firewalls. I'm using an application gateway for WAF functionality behind the firewall. So I have layer 7 behind that. My gateway subnet where I'm putting my managed gateways, and then I have a jump box subnet. So that's what my virtual hub looks like. And then in my spokes, oh, let's look at peering. So in order to peer, I go to peerings. And it's here that you create the peering. So what's interesting is this says disconnected. And what I probably need to do is go into Spoke 3 and finish the peering. So it's a bilateral conversation, meaning when I want to peer, and this is for security management purposes, it makes sense. I have to go into the hub and say, hey, I want to peer to the Spoke, and then I have to go into the Spoke and say, yes, I want to peer into the hub. So each side needs to handshake on that. Remember how I talked about setting up transitive routing? So when you go into the peering for any given 2 VNets, this is where I would say allow gateway transit. This is where I designate a hub as such to say the express route gateway that's in here, I want those routes to flow up into the spokes for transitive capability. Allow forwarded traffic just means allow traffic through the VNet that didn't originate there, and you almost always want it in hub and spoke. Use remote gateways is for spokes, so let's take a look at that. So I go to virtual networks, go to my spoke. Oh, you know why Spoke 3 was disabled? It's because I deleted the VNet. And it was telling me, hey, I don't have a VNet to peer with anymore. So that's what happened there.
Yep.
Okay.
Every time.
Yep, that's right. So here's peering from the other side. This is my Spoke 2 to hub. It's connected. And gateway transit is disabled because I want this spoke to take a dependency on the gateway and hub for transit capabilities. If I were to say allow gateway transit, and we'll try that, Azure would probably be frustrated at me because you can only have one master gateway per VNet, and so I'm trying to break that spoke dependency model that I've created. Use remote gateways is the way that I would bring this spoke into that transit relationship. So that's telling the spoke, use the gateway to hub, and that's what I want. Allow forwarded traffic is what I want because, again, in a hybrid way, packets are going to be leaving and coming into the spoke that didn't originate there, and so I almost always want that. This is just basically allowing packets in and out of the VNet itself, and I would go into disabled mode for security reasons, for lockdown reasons, to basically shunt that off. So again, to allow packets just to flow into the VNet from anywhere, you just want to leave it enabled. So I'm going to save this out. And now all this is going to be, oh, it says failed. Use remote gateway flag is set to true because subscriptions allow gateway transit has set to false. So this is frustrated because my hub doesn't have allow gateway transit turned on. Is that true? So let's go back and figure that out. Thought it did. Sometimes the demo gods are cruel.
Trust me, we are very aware of how the demo gods go during live demo.
Yeah, it's all right. So, peering to spoke 2, that's what I was banging on, right? Let's see what's going on here. Ah, there we go. So it's kind of good for just general education purposes. I want to allow forwarded traffic, and I want to allow gateway transit to my spoke 2 so I can be transitive. So to spoke 2, hub is hub. And so that's what spoke 2 was saying. Like, I can't take a dependency on you, hub, because you haven't offered your gateway to me. So this is kind of a timely way to learn the process. So if I say allow gateway transit, great. Now spoke 2 can really be a spoke. If that makes sense, right? Because now it can take a dependency on the hub. So we'll go back to my spoke 2. And that's an interesting point that you can be transited for one spoke and not the other. So it's very granular. I'm not going to go send that same peerings. Now I can complete a picture. So I can say use remote gateways, and he's going to become a proper spoke. He's going to see routes that come in through my express route circuit. And he's happy now. And one last thing before we split. This is what express route circuit looks like. So I have a circuit with Equinix here. This is being landed in the West End, so the Seattle location, that big data center hotel there. It's been there for a long time. Equinix is the manager of that space. Remember I talked about the different peerings and the different routing domains. Here is my Azure private that I've set up. So I'm sending, these are my BGP peerings. They're not actually the routes I'm sending. This is so BGP can talk over my primary fiber and my secondary fiber. If I want to drill into this, I can get routing information in and out. So the customer tag I'm sending through is 100. This is my peer ASN that my the Equinix BGP side is sending me. These are the two subnets I'm using for BGP to talk over. And for example, if I just wanted to check out BGP, I just go to get route table summary, and it's going to query the MSEE via APIs down the Cloud Exchange. And it should show me some BGP status stuff. This is a little slower because it really is going all the way to Seattle and talking to our metal tier there. Managed metal service. It's all best of breed stuff, by the way. We're not using any white box stuff in Cloud Exchange. It's all going to be basically Cisco or Juniper.
That's awesome to know. You never know what's on the other end sometimes when you're working with these things.
Yeah, that's right. Okay, well, that's a little slow. We'll give it. There it goes. All right, cool. We're all just twiddling our thumbs here, waiting for BGP to load out. There we go. So these are all my various peerings that I have. So this is the primary circuit. What it's showing here, it's showing me an interesting double vision. This is a little 400 level conversation. This is my peer in Equinix. And then these are my two interfaces on my express route virtual network gateway, which is connected to this circuit. And if I want to see my secondary fiber, I would click here and see this. And so our express route virtual network gateway also has two interfaces to match the two interfaces of the MSE topology that we reviewed. And just very quickly, just to see connections, how you would connect a VNet to a circuit. That's done. This is an overview of this connection, but that's done at the virtual gateway level. So the express route virtual network gateway holds those connections to connect to arbitrary circuits. So I can actually connect a VNet to up to 4 circuits and have 4 different Cloud Exchange locations servicing a single VNet, which is really cool. All right, so with that, I think we have approached time. I hope this has been a useful exercise. I know it was a little helter-skelter, but I think it's a valuable learning experience to step through these concepts in that interactive way. And if you guys want to hit me up for further questions, comments, or anything, feel free to find me on LinkedIn. Bryan Woodworth, and hit me up there via chat or message, and we'll continue the conversation. So thanks again to all. Thanks to Thomas for your time. Hope you guys have a great day.
Great. Thanks a lot, Bryan. This was great. We will get your LinkedIn link into the show notes. And if there's any links that you'd like put in there, just let me know and I'll get those in the show notes too.
Will do. Thank you so much. Have a great day.
All right, you too. And thanks everyone for tuning in and joining us at our regular times. The schedule is out at vbrownbag.com/brownbags. Thanks again. Bye.
Sure.